Hi everyone, I'll start by introducing our project and explain some of the sections from this Colab file. So our project is real estate investment analysis using machine learning. And our team name is Team Bayare, which consists of me and my teammates, Revant and Yash. The purpose of this project is to help real estate investors identify properties where the combined HOA fee and mortgage payments are less than the rent, so as to ensure maximum return on the investment. So first we started off with loading the data. So for this we used libraries like Pandas and NumPy for handling and analyzing the data. And we used Matplotlib and Seaborn for data visualization and scikit-learn for machine learning models like decision tree, random forest, SVM, gradient boosting, and etc. We also imported all evaluation metrics like accuracy, precision, recall, F1 score, and ROC AUC. We set Pandas display configurations to show all columns and used filter warnings, ignore to clean up the outputs. And as for setting up the data, we defined our data preparation overview. So for this, we followed a sequence of 4 steps: cleaning so as to fix the errors and handle the missing values, transformation so as to normalize data and encode the categories, and for structuring and optimizing the data, uh, uh, we are using the organization. And for data validation, we are doing this to check the quality and completeness. So we'll start off with our data set one, which has values or the columns like price, rent estimates, area, bedrooms, bathrooms, and address. We clean this data set by dropping the unwanted columns like sold date, currency, and listing URL. And we extracted street, city, state, zip from the address column. And we converted text areas like 2000 square feet into numeric values. And we have filled the missing values with median categorical with mode. And we dropped records like missing latitude and longitude. And we saved the cleaned data set into a CSV file. And we visualized it using correlation heat maps and box plot for area, and scatter plot, which consists of price versus rent. And we also implemented geographical plots using latitude and longitude. We worked on the data set too, which has more structural details like bedrooms, bathrooms, total area, and the year built. And we dropped irrelevant columns like garage, square feet, and renamed columns like we converted sales price to price, and number of bedrooms to bedrooms. Uh, and we filled the missing values with median or mean. We also merged street name and city into a single unified address column. So after data cleaning, we created histograms to show the price distribution, and scatter plot to which shows the comparison of price versus area across different cities. And we scraped a third data set from Zillow using apify.com. So this one included the missing categorical data such like HOA fee, taxes, living area, and lot size. We selected useful columns, converted acres into square feet, removed symbols like dollars, comma, and standardized all numeric data. So after cleaning, we visualize the data using same correlation heat maps and histograms showing features such as price versus rent, price, rent is estimate, monthly HOA, and the tax amount. So as you can see here, the monthly tax amount. And then we'll start with our first amalgamations, as all of our data sets are clean now, and we also handle the missing data values. We started with merging 1 and 2 data sets using pandas on columns like address and price, bedrooms, and area. And we dropped duplicate fields from one clean combined data set as this increased the dataset richness. This integration improved our model accuracy around by 10%, reaching 95.34 accuracy in the classification task. That completed the data preparation and the integration phase. Now Revant will explain the feature engineering, clustering, and the latent variables.
Thank you, Amrita. I'll continue from the feature engineering. So once the data was merged, we trained a random forest regressor to understand which features affect property prices the most, and we found the rent, estimation, area, and bedroom were the top features. We plotted a feature importance bar graph, which clearly showed that rent and area have the highest influence on predicting the property value. And regarding the baseline information, to test and compare multiple algorithms quickly, like we have used the Mueller framework. It's basically a loop that automatically runs several modules and evaluates them and shows the best result. And for the Mueller loop for classification, here we have classified properties into three categories. One is the least desirable, most desirable, and the most desirable. So we tried the 8 different algorithms include k-radius neighbor, linear SVM, RBF SVM, decision tree, random forest, neural network, that is MLP, AdaBoost, and Navy bias. So we have evaluated them using metrics like accuracy, recall, precision, and F1 score. Linear SVM achieved the highest accuracy of 95.34%, like which proved it was the most reliable for this task. And for the Mueller loop, for regression, next we predict the future property prices using regression. We have used several algorithms, like 7 algorithms, like the linear regression, MLP regressor, random forest regressor, gradient boosting regressor, KNN, SCD, and kernel ridge. We have evaluated them on R square, RMSE, and MAE. So the gradient boosting regressor gave the best result, that is R square is equal to 0.91, meaning that it predicts were almost identical to real values. So we performed clustering to identify natural property groups. First, we used k-means for Euclid distance to create the cluster, like budget, moderate, and premium. Then we have applied the fractional clustering, which used a custom fractional distance function to deep nonlinear patterns. So this reveals like the golden cluster, a set of properties where HOA plus mortgage is less than rent, representing the best investment group. So finally, we have enriched our data set using latent variables from external government sources like EPA's Smart Location Database. We have added metrics such as walkability index, employee type distribution, percentage of low-wage workers. So these factors helped the model become more realistic and location aware, improving the interpretability and performance of our predictions. That conclude my section. So from here, like Yash will explore the final part involving the HOA integration, final classification, regression, and saving the models.
Thanks, Revant. I'll explain the final part of our collab where we connected HOA data, built the final models, and saved them. So coming to the HOA integration and target definition, we used a dataset containing median HOA fees by metro area. We mapped HOA values to each property using the address. Then we created a few features such as the motor gauge HOA, which is the HOA plus price times 0.0062, where 0.062 is the average monthly motor gauge rate. We compared this with the rent to define our target variables. If the motor gauge HOA is greater than the rent, then it's least desirable, and if it's less than the rent, that's the most desirable. So this automation, sort of helped us to automatically label our data for classification. We ran classification again on all 4 versions of dataset 1, dataset 1 plus latent variables, amalgamation, dataset 1 plus 2, amalgamation plus latent variables. So we saw that the linear SVM model gave us the best result with about 95.3% percent accuracy and clear separation in the confusion matrix. Yeah, and then moving to regression using the Mueller loop, we used same versions and predicted property prices for 1, 2, and 5 years. Gradient boosting regressor again performed best with R square of 0.91 and very low root mean square error. This proved that a model can forecast future price is appreciation accurately. And finally, we saved both best models using Pickle. So you can find one in linear_svm.pkl for classification, gradient boost regressor.pkl for regression. We then loaded them back and plotted prediction histograms showing the price and desirability distribution. This completes our Colab implementation. Yeah, thank you.
Yeah, so our paper starts with the abstract and introduction. We explain that manual property investment evaluation is slow and biased. So we used machine learning to automate it. The paper's goal is to find properties where HOA plus mortgage fee is less than the rent and predict value appreciation using clustering, classification, and regression. The business objective section explains our ranking system, which is like least, more, and most desirable, and how we forecast price appreciation for 1, 2, and 5 years. It also emphasizes reproducibility and transparency. And in data sources and amalgamation, we describe 3 data sets. The first data set is base model, which was provided by our instructor, and the second data set which has structural info, and the third data set which was scraped from Zillow. We merged them using pandas and achieved a 10% accuracy improvement due to better feature richness. Moving on to the next section, Revant will explain it.
Amrita, can you please go to next page? Yeah. So here, we have focused on the core model sections. So we presented the visualization like correlation, heat maps, scatter plots of price versus rent, and geographic maps. Then we described feature engineering, adding new columns like mortgage, and integrating the latent factors such as a crime rate and walkability. We used random forest to find the top features for the area, rent, and bedrooms. And then in the clustering analysis, we have discussed how k-means and fractional clustering reveal property groups, especially the golden cluster when rent far exceeds ownership cost. For classification, we summarized our results. The linear SVM gave like 95.34% accuracy and outperformed all other algorithms. For regression, the gradient boosting regressor achieved R square is equal to 0.91 and predicted future prices accurately. So this section visually show our predictive success. So the Yash will continue the next section.
Yeah, so on the following pages, we covered model evaluation, results, and conclusion. We compared models using accuracy, recall, precision, F1, RMSE, and R square. We also added added a comparison of adding latent variables and combining data sets, which showed us consistent improvement of every metric. In results and discussion, we highlighted how the golden cluster was the most profitable segment. Gradient boosting gave precise price predictions, and linear SVM classified investments desirability perfectly. Finally, the conclusion emphasizes how our approaches combining structured data engineering features and explainable AI simplifies real estate investment for everyone. Thank you.